So, well, no, that's not the right one. Just a quick little recap of important ideas from the last lesson. And then we're going to get started. Okay, so this theorem is called the tan chord theorem. And that's because the angle between the tangent and the chord is equal to the angle in the alternative segment. So that 63 and the 63 are in a relationship, an equal relationship. And the same is true from the other side, except the angle is different. Now, the cool thing about this theorem is even if we move things around, you'll notice that the angles may change, but the relationship stays the same. So this is called, let's make it a bit thicker so you can see. This is called the tan chord theorem, or the windsurfer theorem sometimes. And it's going to come up a fair amount today. Then we also spoke about in the last lesson, the relationship between a tangent and the radius of a circle. So if we look at a tangent, and it has a point of tangency, we can see I can move the tangent around, but the relationship between the tangent and the radius is always 90 degrees. And so we call that the tan radius theorem. And then the last one that we spoke about in the previous lesson is tangents from a common point. And this just has that if we have a tangent from a common point, the length from the common point to the point of tangency will be the same for both tangents. And it doesn't matter if the common point is closer. If it's closer, the tangent lines will essentially be shorter, sorry, but the relationship is the same. And these are called tangents. It's not the way, tangents from common point. Tangents from common point. Okay, so that is, now obviously we also have week 1, which was circles in the center, and week 2, which was circles and cyclic quads. But let's go and do some practice questions. So I want to start by doing number, I don't think we've done number, let's go to, let's do this one. I don't think we've done number 6 yet. Tell me if we have, but let's do number 6 and let's do number 7. So 6 and 7. And finding 6 is going to be about finding n and finding m. And then 7 is going to be about finding x and about finding y. So if you are unsure or would like some feedback, I want you to raise your hand or make a comment. But otherwise, I want to see if you can do these questions. And think about which of the theorems are involved here. Okay, so what are we going to go after first? I want to see some answers. So I really do want to see you putting the answers in the chat. You don't have to put all the reasons, but just give me the numbers as you get them, so I know if you're doing things or not. that is quite an important part of the process. We also know by being active, you learn better. So I spotted, maybe you did too, that those must be equal. What else is involved? I see a tangent and a chord. So maybe this angle over here is equal to the angle up here. So we would say PRS is 32 tan chord. Now, if that's 32, what is my M going to be? Because remember, M is sitting down here. So what is M going to be? Okay, I agree. M is 108. Sum of angles in triangle. Okay, so that is going to be 108. Now, we have to go after the N. So what else can we do? I am noticing that it would be super helpful to figure out what that angle is. Can anybody help me figuring out QRS? Can anybody help me find QRS? What do we think that is going to be? Okay, I agree, Siamtanda. And I think what you saw is that if I use that red chord, it is going to be equal to that. So this would be 40 by the tan chord theorem. Now, if this is 40, we're now in a good position to go after n. What is n going to be? What is that going to be? I think I agree, Ronnie, because I know that these two are equal. Well, actually, I don't even need them to be equal, to be honest. I can probably just go n is equal to 180 minus 72 minus 72, and I'll get my value of 36. And then the reason would be sum of angles in triangle. Okay, so that wasn't too bad. See if you can do number 7, which is finding x and y. Similar idea. Ooh, Atlikhang, thank you for your question. Okay, here's the thing. The angle at the center theorem only works if you have basically the n isn't on the circumference of a circle. So S is not the center of a circle. So you only get to use angle at center is twice the angle at the circumference in the situation where you have an angle at the center and then you have an angle at the circumference like that. Or you could also have it in other ways, but the problem is S is not the center of the circle, and that's the problem. Okay, so I hope that's helpful, Atlechan. You maybe tell me if it is in the chat. But it does look a bit like that. Hey, it does. I was also kind of. Now, what can we get? What would I go after first here? I think I would go after X first. Yeah, Ronnie, I completely agree. X is 50, and that would be the tan chord theorem. So this is 50 over here. Oh, and that makes y quite easy, actually, because this is a straight line. And we know that angles on a straight line must add up to 180. So we'll just say angles on a straight line. Now, what is that y value going to be? I'll try and do it in my head, but maybe somebody can help me in the chat. We have 112, so 8. So I get 68. Okay, 68 degrees. Awesome. Okay, well, let's see. Can you do for me? So take a screenshot if you need to. I'll just give you a moment to take in number 7, and then I'm going to move on. Just give me a thumbs up if you're ready to move on. Okay, so let's do number 10 and 11. Let's do number 10 and 11. Number 10, I am solving for M and for K. And then also in this one, I'm solving for that, that, and that. So put your answers in the chat so I know what you're getting, like M equals or K equals, just so I know the pace, so I know at what pace to explain. Right, let's have a look. Now this is helpful. So those are isosceles triangles. But you know what? This is a tangent from a common point. So these are also, so those are equal, which means this must be K. So CAB is K, and that is angles opposite equal sides. Now that can be very helpful in finding what K is, because we can go 2K plus 54 is 180. And then we get 2K is 126, which means K should be 63. So both of these angles will be 63. Now, what is angle M going to be? That is the question. Where do we go next? I see these two blue things. I wonder what they do. I suppose they make them equal, huh? Oh, I'm just thinking if we could get, hold on, tan chord. tangent chord, I think we could work out what this is, because it's the angle between the tangent and the chord. And so D must be 63, which means that must be 63 because those two are equal. So what is M going to be then? Did you follow that, everyone? So I said angle D was 63 by the tan chord theorem. And then I said angle DCA is 63, and that would be angles opposite equal sides. Now I need to figure out what M is. Why is K not 50 for the tan chord theorem? Okay, well, here's the thing. I'll show you now. Why is K not 50? Because there's no 50, so the K can't match to a 50 degree somewhere else. So what I was thinking is that this thing here must be 180. And so M must be 180 minus 63 minus 63. So what are we going to get for that? Okay, so we get 120, 126 plus 4, 1. So 54. Did anybody get 54? I get 54. Now, you will notice that you would also get 54 for this one because those are in that relationship. Okay, let's try and do number 11. So I'll just wait for the answers. No problem, Ronnie. I see that you've got it. So for number 11, K would in fact be 50. So you're correct. So K is 50 by the tan chord. So tan chord. So this one is 50. What's the next one I get after that? I'm going to zoom in on this, just so it gets a bit more focus. So we know that that is 50. All right, now, what are we going to go for next? Oh, wait a minute. I just noticed this. So then M has to be 50 as well, because, okay, let's write this in. K is 50 by the tan chord. M is 50 by angles opposite equal sides. What is N going to be? What is N going to be? Oh, that's actually quite easy as well, because it's angles on a straight line, which means N must be 80. Okay, so that's 80. Now, what's the last one? It's P. What is P going to be? Well, actually, I see a triangle, so there's really not, or I could use the tan chord. I could say, in fact, let me use that because it's what we're doing today, but you could use sum of angles in a triangle, or you could see the shape you make here. This thing has to be 50. Like that. Oh, sorry, I lie. I'm making things up. Sorry, my brain went, my brain went off the boil there. P should be 80. Thank you. I had a bit of a moment, an old person moment. Okay, I want to squeeze in one more before the break, but before I do that, I want a reality check from the students in the class. So 10 out of 10 if you feel like you get everything perfectly, 0 out of 10 if you feel like, oh my goodness, there's no hope. 5 if you're kind of in the middle. Let me know in the chat how you're feeling so I know what type of questions to choose going forward. And be honest, because remember, I can't see your body language, so it's hard for me to know kind of what exactly is going on for you. I get a feel from the chat, but okay. Cool. Thank you for your votes. They are much appreciated. Let us start with, let's do this one. It's a little bit harder, but it's cool. It's a nice question. So in this question, our last one before the break, we are going to try and find y, w, x, and z. But in addition to tangents, and there are tangents in this question, there are some other things that are quite useful, like a center of the circle. And I think I even spy a cyclic quad as well. So I want you to tell me, where should I start? Where should I start on my journey to find angles? And I want someone to give me tell me why and where should I start? I agree, Simtanda and Ronnie. And the reason W is such a good thing is that this is a relationship that we understand. They are opposite angles in a cyclic quad. So what is W going to have to be? Just to point that out, if you haven't spotted it, this point, this point, this point, and this point are all on the circumference of the circle. And so that's why we have this relationship that we spoke about in week 2. So we know that actually we are just going to take away all the angles and we should get 158 plus 222. And that would be the, not the tan chord, that would be the opposite angles cyclic quad theorem. And this is going to be 22. Okay, where do we go next? Where do we go next? X, I agree. What theorem are we going to use to help us with X? It's a bit hidden, but there is a radius line and there is also a tangent line. And so we know this must be 90. So therefore, X must just be 90 minus 22. And the reason is the tan radius theorem. And what is 90 minus 22? It is 68. So this is 68. Okay, good news. Things are going well for us. Where do we go next? Nice, Simtana, nice. Where should I go? Well, what I haven't made a big deal about is these are two tangents from a common point. Now, I think that makes it a bit easier to go after Y, but oh, Z, you know what, Simtanda, you're right. Z is actually, it's hiding, but if we go like this, oh yes, of course, Z is just going to be the tan radius theorem. And so Z would be 68. tan radius. Tan radius. Okay, last one is the y. What is the y value going to be? Nicely done. All right, so now y is going to be, indeed, so 180 minus, now there's a 68 here, so it must just be like that. So we have, what do we have? 120, 128, 136. This has to be 44. That would be the sum of angles in a triangle. But it would also be the fact we used the reason angles opposite equal sides to help us. So angles opposite. Because we used that to get the 68, which helped us get the y. All right, everyone, you've done really well. I like what I'm seeing. There's lots of good feedback and activity in the chat, which is fantastic. And in order to have a fantastic second half, I want us all to stand up. If you can, turn on your camera. It's very helpful to feel connected as we go about to do our exercise. And we do this because we know our concentration span is limited, and it's much better to take 5 minutes out now, unwind, relax, and then you'll get much better quality later on in the lesson. So first thing we need as people is oxygen. So let's breathe. Breathe in. One more deep breath. Breathe in. Okay, so that's oxygen into our body. Now let's loosen up so we're not too tight or stressed. Let's pretend like we're in drama class. We're just going to shake our hands around a little bit, shake this arm around, get nice and loose, nice and relaxed. If you feel silly, that's fantastic. It means you're doing the right thing. And shake out your legs, shake them out. Your body will pay you back, I promise, for this TLC. Okay, let's roll our shoulders. So we're rolling them back. And then let's roll them forward. Okay, then out to the side. And we are doing small circles going forward. And then we're going small circles going back. And then arm up behind. Let's do a tricep kind of stretch. This is great for when you're hunching over with your shoulders and you just need to chill out a bit. And then switch to the other side. Okay. So let someone in. And then the last thing, well, for the little brain break, we're just going to do some jumping jacks, which go like this. And that's just to get blood moving through our bodies. So let's go. We'll do like about 10 or 12. 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. And I hope that your body is feeling a bit looser, like you have stopped thinking about maths for a little bit. And then I want you to try and do this riddle. So that is your riddle for tonight. You're given 3 positive numbers. You can add these numbers and multiply them together. The result will be the same. What are the numbers? What are the numbers? Put your answer in the chat and you can be the champion of the riddles for today. You're on the right track, Siamtanda. You're almost there. Okay, zero doesn't, you're right. Okay, so zero is the sneaky one, but they're positive numbers. So the zero is not included. Okay, I'm going to give you the answer now. It's so, you're going to click your, yes, Silicania, 1, 2, 3, exactly. So 1 plus 2 plus 3 is 6. And 1 times 2 times 3 is 6. Oh, sorry, Ronnie, I didn't see your hand. Well done. That is impressive. That's a good riddle, huh? I can see you guys enjoy the riddles. So I'll see if I can keep finding a couple of these and I'll bring Maths 24 in between. Okay. So after that fun little break, we are now ready to re-embark on second part of the lesson. We will start to look at some exam questions as well, but let's just do this one. Find me X, Y, and Z in this question. See what you can do here. See what you can do. I think I would go after the Y first. But that's just me. Maybe you would do something different. What is Y going to be? Yeah. So angle at center equals twice angle at circumference. So this is 49. Now, what has been cut off a little bit is that this is a common tangent. So that's a tangent from a common point. So just to make sure you see that, we know these two are the same. But does that help us? What other theorems might come to? Ooh, I've just spotted one. Where should we go next after Y? Okay, so Ronnie, about your construction questions, normally the construction questions will happen in what's called proving a theorem or the proofs. So if you had to try and do the proof of the theorem, the angle at the center equals twice the angle at the circumference, then there are extra constructions that you do. But generally, when you're just figuring out the size of angles, you don't need to find, you don't need to do constructions. Now, unfortunately, Z is not the opposite angle of a cyclic quad. The problem is there is no circle that goes through these 4 points. So you can't do that. The better one to go after is X. What do you think the size of angle X is? What do you think the size of angle X is? Okay. I think that this is a tangent and this is a radius. So what do we know about the angle X? What do we know about the angle X? It's 90. Yeah, it's tan radius theorem, and it's going to be 90. It's just that the tangent is so funnily written like up on the side here, but it is 90. So let's put that in here. Now, what do we know that could help us here? There's a tangent there. Ooh, what's W going to be? I just had a bit of a realization. Yes, Simtanda, you're right. 90 is also, it was like hiding from us in plain sight. So that's also 90. Now, we can't use Z as the opposite angles of a cyclic quad because we don't have a circle that goes through these 4 points. We don't know that's the case. But what do we know about all quadrilaterals? What do all quadrilaterals add up to? And maybe we could use that to help us figure out what Z is. Yeah, all quads add up to 360 because they're essentially two triangles. And so Z is not 360, but I can use 360 minus 90 minus 90 minus 98. And that would just be sum of angles in a quad. And what is Z going to be then? What is Z going to be? That was quite a sneaky one, the way those tangents were hiding like that. On the tangent and the radius relationship. Yeah, so this is going to be 82 degrees. So this one over here is 82 degrees. Okay, take a screenshot if you need to. But then we're going to move on. All right. Cool. So let us do number 12. And for number 12, you have to find me the size of n, but you also have to find me the size of p. And you are given, this is 28, and you are given that this is 44. So where do I start? I do notice these are radii, which might be helpful. And I do notice that that's a tangent. So that could be helpful. I do notice there's an angle at the center and something at the circumference. So that could be helpful. Where would I go first? I think what I would do is I would say this is 44. I think I would go for that first. Now, somebody else might have done it differently, and that's fine. But I just want to put that there so that I know I have it. And I'm going to say that is the tan chord theorem. And so if I know this is 44, I then feel like I can work out what this is. And that will be AOC being 88. And that will be angle, let me do it below because I'm running out of space, but angle at center equals twice angle at circumference. So this will be 88. Ronnie, yeah, let's go to you. What is your question, Ronnie? I'll unmute you now.
So I understand what you've done. I just have a question. Since
Yeah,
both B and O are opposite angles towards the chord AC, why didn't you say O is also equal to 44?
O is equal to
And then,
40. Say that again so I can, I'd say that again, just so I can.
since both angle O and B are opposite chord AC, therefore O can also be 44, but then it will be still half of B. But B can also be 44, but it will be double of itself being
Yeah, so
88.
I don't think this one over here, I'm not sure if I can explain perfectly, but this one has to be double the size of this one because of the angle at center is always twice the angle at circumference. And you're right, the common chord is this AC over here. But then so that part is fixed, but we used the 44 over here to help us. So the next thing I was going to do, I don't know if I can answer your question, because I'm not sure but what I was going to do next was I was going to go 180 minus 88 divided by 2. Would that make sense?
Yes, sir.
So that would be radii and sum of
Angle,
angles
angle.
in triangle. So then what would P be then? What do we think P would be? I think it would be, so 100 minus 8 is 92. What's 92 divided by 2? I think it's 46. Yeah. So 46. Yeah, there we go. Thanks, Ronnie. Thanks, Silicane. So we know that P is 46. I can even just do it here. Now we need to find what N is. Interesting. Now, we could also say that this is a tangent and this is a radius. Now, I haven't brought this up, but this is 90. Do I maybe know what this angle over here is, what we would call the green dot? I'll call it the green dot. Or if it was an O here, it'd be, oh, there's no O. But I was thinking maybe we can work out what the green dot is and then subtract it from the 90. So we can say that DCO is 90, and that's just the tan radius theorem. What is the green dot going to be? Well, it's going to be by the tan chord. The green dot is going to equal whatever these two angles are. And that is going to be 68 plus 674, which means N must be 90 minus 74, which is 16 degrees. And so N would be 16. All right, one more question for today, and then we are done. Give me a thumbs up when you're ready to move on. Give me a thumbs up when you're ready to move on in the chat. Keep those thumbs flying. Okay. Now, last question for today is like a exam-like question. And I'll show you the mark allocation. Just to go over what you've got. O is the center of the circle. STU is a tangent. So STU is a tangent. We also are given that BC is equal to CT. So BC is equal to CT. And we're also given that ATC is 105. So ATC. So this one is 105. And CTU, where's CTU? CTU, this one is 40. Can you find for me the size of angle A2, which is sitting up here? What is, oh, please redo. Which part, Ronnie? Let me quickly just, I'll make that one a bit smaller so everyone can see that. What part did I lose you on, Ronnie, in terms of the question above? Did you get the N part? Okay, so basically for the N part, we knew where that blue big thing there is. Basically, we knew that this must make a 90-degree angle. And then we said that the angle between here and here is equal to the angle down here, which was 28 plus 46, which was 74. And then so the blue bit that's hiding a little bit now is just 90 minus 74, which is the 16. Let me know if that helped a bit. And then for those who are working on A2, what are you getting for your A2 answer? What are you getting for your A2 answer? I'm seeing, let me make it a bigger, pleasure, Ronnie. I'm feeling a bit of tan chord in my life. So there's a tangent, there's a chord, and there is that one. So what is A2 going to be? Pop your answer in the chat. It has to be 40, yes. Oh, Stephen, I saw your hand was up. Let me go to you. What is your question, Stephen? How can I help?
So I wanted to answer, but also tell you what I was thinking of A2. And I wanted to maybe also ask you on that question because I'm not too sure on that one.
Okay, so A2, can you see the green angle over here? Can you see the green bit
Yes,
that's 40? Now, what we say is that chord subtends the angle
Yes,
up
sir.
here, which is, so are you good with that one? Now, A1
Yes, sir.
is the next bit. That's a bit more tricky, hey?
Yes, sir.
Now, let's try and figure this out together a little bit. Okay, what makes this one? Yeah.
So to interrupt you, because the reason why I'm asking you this, because I was going to solve it separately, because I was going to solve it as T1 plus T2 plus T3 equal to 180 angles around the point. So I was going to study like that. Then I was going to say T1 equals to C3. Then I was going to say 10 chord.
I think I agree with you. There's nothing wrong with what you're doing. I'm not sure if it'll get you to the answer because I haven't got the answer myself yet. But this is definitely not 145. It should just be 35. So it's not 145. Sorry, that's me. This should be 35. But
And then
in
you're
terms
still
of
going to
getting
give me
A1,
40.
yeah, I was thinking, could we say that this is a cyclic quad over here? Well, no, that's not going to be helpful. So that's 75. It's opposite that. What other stuff haven't we used yet? Oh, okay. This is a sneaky one. I've just understood what it is. It's hiding. Can you see the BC equals CT part? Now,
Yes, sir.
there's a theorem which says equal chords subtend equal angles. And so what I've noticed is that there are two equal chords that are sitting here and here. And what they do is the one chord subtends that angle at 40. But you know what? Because the chords are the same, what size is A1 going to be? It's actually going to be 40 as well. And the theorem is called equal chords, equal angles. I'll give you a little demonstration now, but equal chords, equal angles. And it's the one that I did in the first week where I said, look, if you have a circle and the chords are equal, if you make an angle at the circumference here, and then you do, let's say, the same thing here, those angles are going to be the same size because of these equal chords. And so this is going to be 40. that is a little bit sneaky because it's hiding that theorem kind of on this thing here. Okay, now let's go on to B. What is angle B going to be? I'll give you a hint for that one. Angle B is definitely going to be related to this 105 over here. I think this is a cyclic quad. And what do we know about cyclic quads? Well, the opposite angles in a cyclic quad are add up to 180. And so I'm going to say opposite angles cyclic quad. So this is 75. Yeah. Now we're running out of time, so I'm going to speed up a little bit for this last bit. And also it's worth 6 marks, so it's probably quite a bit of work. So I want to say that is 80. All right. And that's 80 because it's double the angle at the circumference. I then want to say that this is 50 and this is 50. But remember that this one was 75, so that actually has to be 25. Okay, now we still haven't got C2. Where is C2 sitting? It's over here. Okay, now, do we know the size of the big, I'm going to draw a line across here. Do we know the size of the big black angle? I will call that BCT. I think BCT is the opposite angle in a cyclic quad, so it is going to be 100 in total, because that's 80. Is there anything else that we can still, we need to figure out what C2, which is this one over here. Oh, look, 40 and 105, this must be 35. So what is angle C2 going to be in total? What does angle C2 have to be? This was a bit tricky, but I think you can see the logic, and you can always re-watch this again if you need to. But who can tell me what C2 is going to be? It's going to be 15, yes. So this is going to be 15. Now, there was quite a bit of work. So just to show you what I did, I said 40, and that one over there is 80. I then said these two are 50. I then said that this one over here is 35. And then I said, well, together, these two are 180, so that must be 15. All right, everyone, that last one was a bit of a toughie, but I think